Hello, it's Mrs. Hoekstra here. I am starting Lesson 9 in Module 3 using if-then moves in solving equations. This is kind of like part 2 because Lesson 8 was using the same idea. You'll notice my essential question on the top of page 67, and it says, how do I keep track of all the information given in a story problem? Because there's a lot of information that's going to be given to you, and we need to kind of keep it organized so we know what's going on. All right, this is a pretty short lesson, so we're going to jump right in. Heather practices soccer and piano. All right, so let's keep track of that. She is doing both of these. Each day she practices piano for 2 hours. We automatically know that. That is a given 2 hours each day. Each day she practices piano for 2 hours. After 5 days, she practiced both piano and soccer for a total of 20 hours, right? So she has a total of 20 hours. Assuming that you practice soccer the same amount of time each day, right? Practice was the same number of hours or minutes or whatever every day. How many hours per day, H, did Heather practice soccer? All right, so we're going to use the letter H, right, to represent the number of hours per day that she is practicing soccer. All right, well, it says that she does both soccer and piano. Well, we don't know what the soccer is, so we're going to put the letter H. Plus, we know that she practices piano, and we know how many that is. We know it's 2, right? We know that that is the 2 right there. And she does this for 5 days, right? It says that she does this for 5 days. For a grand total, right, there's our 5 days, for a grand total of 20 hours. See how I did all that? So she has the hours she practiced for soccer, that's the purple H, plus the 2 hours every day that she practices for piano, right? She does this every day for 5 days, there's the red 5, and it gives her a total of 20. Well, then the question is, well, how many hours did she practice? So, if you notice, we have that beautiful 5 out front, so we're going to distribute. 5 times H is just that, 5 times H. And 5 times 2, so plus 5 times 2, and all of that equals 20. All right, well, 5 times H is 5H, 5 times 2 is 10, and that equals 20. Well, I would like to get the numbers all to one side, so I'm going to subtract 10 over the other side, and by subtracting 10 to both sides, I've kept everything equal. It's all balanced. I can use that if-then move. Those 2 cancel out and become a 0. That's what I'm looking for. And I have 5H is equal to 10. Well, instead of multiplying by 5, I can multiply by its reciprocal, right? The multiplicative inverse of it. So if I multiply by the multiplicative inverse, these become the beautiful number 1, which is what I'm looking for. And I get that H is equal to 2. So she practices soccer 2 hours per day. 2 hours each day. Well, let's see a different one. So over 5 days, Jake practices piano for a total of 2 hours. Okay, so again, we're looking at that 2 hours for piano. But he does that over 5 days. He's not doing it every day, right? Jake practices soccer for the same amount of time each day, all right? And we're going to figure out how many hours he is going to practice. And once again, there's a total of 20 hours for the whole week. So this one's different, right? Because he only practiced 2 hours over the whole 5 days. So instead, we now have the 5 days times the hours at soccer. We don't know how many that is, plus the 2 hours he's practiced for the entire week of piano. And that still is equal to 20. They both put in 20 hours of practice, just set it up differently. All right, well, I'm going to solve for the number of hours that Jake has been practicing soccer. So I'm going to subtract 2 from both sides, because what I do to one side, I can do the other. That cancels that out, makes it a 0. That's beautiful. I now have 5H is equal to 18. I'm going to multiply both sides by the multiplicative inverse. It's reciprocal. Unfortunately, 5 doesn't go into 18 evenly. So 5 goes into 18 3 times with 3 left over. 3 3/5, or you could say 3.6 for those of you who like your decimals. All right, hours. each day. So he actually practices more every day for soccer, but she's actually probably doing what? More total, because she's doing 2 hours of piano and 2 hours of soccer. All right. Let's see what else is going on. Fred and Sam are on a team in the local 138.2 mile bike runathon. Oof. Fred will compete in the bike race and Sam will compete in the run. Fred bikes for an average of 8 miles per hour. Okay, Fred, 8 miles per hour. And Sam runs an average of 4 miles per hour. The bike race begins at 6 a.m. Ooh, it starts at 6 a.m. Oh, poor kid. 6 a.m. followed by the run. Sam, right, the guy who's running, predicts he will finish the run at 2:33 a.m. Finish at 2:33 a.m. the next morning. So how many hours is this race going to take them, right? So 6 a.m. to what? 2:33. That's pretty specific, but 2:33 a.m. How many hours is that? Well, if I just go 6 a.m. to 2 a.m., right? 6 a.m. to 2 a.m. the next morning, that is 20 hours, right? That's 20 hours. And then we've got that 33 minutes left over. Well, I need everything in hours because we're trying to figure out their race, right? And we want to figure out how long it's going to take each one and how many miles they're going and all that. So I need it to be in miles per hour because, look, the rates are in miles per hour, not miles per hour / minutes. So I got to change my 33 minutes into hours. So I'm going to divide that by 60 minutes so that I can get this into miles per hour. So I'm going to reduce that. 3 goes into both of those. That's 11 over 20. And then I can just multiply everything by 5 to get it over 100. And I ended up with 0.55. Yes, I know it's a decimal, but they gave me decimals in the problem, so I'm going to kind of go with it. 0.55 hours. So if I put my 20 minutes and my 0.55 hours, it's 20.55 hours. Now I know a lot of you are looking at that 5 going 55 minutes. You said it was 33. Remember, 33 minutes is about a half of an hour, right? A little more than a half an hour. So I've got to have it make sense that it would be, 0.55, a little more than half of the 20 hours. All right, I'm going to go over to the next page. If T is how long it takes Fred to complete the bike race in hours, write an expression to find Fred's total distance. Well, what I want to do is go across the page. You'll see it 2 tables across the page, right? Go over one more page. You see these tables here? I'm not going to worry about this top one. I want to figure out this bottom one down here. Okay? So what we're going to do is we're going to use this blank space here, and we're going to keep track of our 2 guys. We've got Fred, and we have Sam. All right, and we want to keep track of the rates that they're going, like how fast are each of these guys going, riding bike and running. I need to know how long they're going to be, the time, and then distance. Because what you do is there's a formula, and it says distance equals rate, their speed, times time. So if I can figure these things out, this becomes really easy. So flip over back to page 67, and it says that Fred is biking at 8 miles per hour, right? And then on the top of page 68, it says we're going to say it takes him T minutes or T hours. So we're going to just put the letter T in there. Well, I just told you there in that formula, distance equals rate times time. Rate is 8, time is T. So Fred is going to be 8 times T, or just 8T. Now Sam, it says he is running 4 miles an hour on average. We don't know how long it's going to take him. Whatever Fred takes up, because he's going to be biking for quite a while, whatever time it takes Fred, right, subtract it from the original, the full amount. Remember, the full amount, this is the full race up here, full time that they're going to be racing. So if I take the time 20.55 is what they're thinking is going to take them to do this, complete this whole race, minus the time it takes for Fred. I'll have however long it's going to take Sam. Okay, it's a little tricky, I know. So what we're going to do for distance equals rate, 4, times time, that great old mess there. So I'm going to multiply 4 times 20.55 minus t. Okay, there's how we're going to figure out those formulas. So notice this nice chart kind of helps me keep it all organized. There's several problems that you're going to be doing for homework that are going to be set up similar to this. So I recommend making some kind of a chart like that. All right, back to page 68. You can obviously flip back and forth or see across the page to be able to transfer the information. So if t is how long it takes Fred to complete the bike race in hours, write an equation. So we know that his distance, and we're just going to copy the information from across the page, is equal to 8t, right? That's what we have for Fred. So what is the one for the, what do we say, time for Sam? Time for Sam, look under the chart at Sam, we should have 20.55 minus t, right? We got that one for Sam. So what is Sam's distance? The distance for Sam we have is equal to 4 times 20.55 minus t. Okay? Then part E, write and solve an equation using the total distance of both, did you catch that? Total of both Fred and Sam will travel. Okay, well, looking at what we have, we know that Fred is what? Actually, you know, I'm going to write down Fred plus Sam equals total. There's my game plan. So what do we know about Fred's distance? Fred's distance is 8t. What do we know about Sam's distance? Sam's distance is 4 times the quantity of 20.55 minus t. And what is the total distance of the entire race? 132, is that right? 138.2, excuse me, 138.2. 138.2. I bet we could solve that. Where would you start? I would start with the distributive property, and I'm going to SMATO also at the same time. Okay? So 8t plus 4 times 20.55 plus 4 times negative t, because I'm going to SMATO that, equals 138.2. All right, so I have 8t plus, this becomes 82.2. When you multiply that out, you can grab your calculator to do it, plus negative 4t equals 138.2. All right, 8t plus negative 4t, right, because I'm just going to change the order, plus 82.2 equals 138.2. Let's combine those, and I end up with 4t plus 82.2 equals 138.2. Now it's all been simplified. You remember all that stuff we did at the beginning of the book? Now we've simplified it. Let's move things around using the if-then moves. So if I'm adding on both sides, I can subtract. So I'm going to subtract 82.2 from both sides, because what I do to one side, I have to do the other. When you do subtract, if you're not using a calculator, be sure you guys are lining those decimal points up. Okay? Those 82.2s are going to cancel. And now I have to take 138.2, subtract 82.2, and I get the most beautiful, wonderful number of 56. 56. Well, multiplying by 4, I can multiply both sides by its multiplicative inverse, 1/4. Or you can remember just to divide by 4. If you're multiplying by 4, the opposite is to divide by 4. And you are left with t is equal to, and then whatever 56 divided by 4 is. In this case, it ends up being 14. All right, so t is 14. Woohoo! Wow, great. What's that mean? It means that Fred is on the bike for 14 hours. Fred bikes 14 hours. Oof, it's a long time. Let's see here. What about Sam? So I'm going to take Sam, 20.55, subtract 14. That means it's going to take him 6.55. Remember, line up your decimal points. 6.55 hours. Sam runs. Okay. Sam is running for 6.55 hours. Fred is biking for 14 hours. That's a long time for both of those guys. All right. How far? Ooh, how far? That's a distance thing. Will Fred bike? And how much time will it take him to complete his leg of the race? Well, we know how long it's going to take him, right? So all we have to do is use the formula. Distance is equal to 8 times t. Because I know what t is, boom, from right here, I can just drop it in. 8 times 14. 8 times 14, how far is he going to go? He's going to go 112 miles. Sounds almost like an Ironman. 114 miles in 14 hours. Wow, long time, long distance. All right, how far will Sam run? So again, I'm going to use the distance formula that I have here at the bottom of the page. Distance is equal to 4 times 20.55 minus t, which in this case is 14. Or we know that this is 4 times 6.55. So 4 times 6.55, I find out that my answer is 26.2 miles. Does that sound familiar to anybody? Anyone know what a 26.2 mile race is called? This is called a marathon. Because in ancient Greece, the two cities were 26.2 miles apart, and the guy had to run and tell the people in Marathon to be aware that they were going to be attacked. So that is why we now have marathon races, and that's why it's that crazy length. All right, next page, page 70. Example 2. Shelby is 7 times as old as Bonnie. If in 5 years, so we're talking about in the future, the sum of Bonnie and Shelby's age is 98, find Bonnie's present age. All right, so we have 2 people to keep track of, and notice we got this chart. So I'm going to keep track of Bonnie and Shelby. Okay, we're going to keep track of Bonnie and Shelby. And we're going to keep track of their present age, right, how old they are right now, and their future age. Okay, because in 5 years, there's the future. Well, let's talk about what we have going on. Shelby is 7 times as old as Bonnie. So since I don't know how old Bonnie is, I'm going to label her X. I don't know. And I know that Shelby, it says, is 7 times that age. So if Bonnie is X, Shelby is going to be 7 times that, 7x, 7 times x. Well, the future age, it says they're going to be 5 years. So this is in 5 years. So let's suppose Bonnie is a brand new baby. How old will she be in 5 years? She'll be 0 plus 5, right? She'll be whatever she is right now plus 5. So for Bonnie, her age is going to be x plus 5 because we're going to add 5 years to her. Same thing for Shelby. Shelby is going to be 7x plus 5. The other thing I know is that in 5 years, their sum, ta-da, plus of Bonnie and Shelby's age is, ta-da, equal sign, 98. So if I take these 2 here in this column, they're going to equal 98. Just those 2. So let's write out our equation then. So we have Bonnie, right, plus Shelby equals 98. There's the game plan. Well, Bonnie, we know, is x plus 5. Shelby, we have figured out, is 7x plus 5. And we know that this equals 98. I'm going to rearrange it, simplify everything on the left-hand side before I do anything with simplifying or solving it. So I'm going to have x plus 7x plus 5 plus 5. Just rearrange everything, get it all nice and neat, put things that look alike together, right? Order, put the x's together. So now I have what? 8x plus my two 5's together. That's 10 equals 98. Well, now I have everything cleaned up on the left-hand side. Let's move things around. If I can add 10 to both sides, I can also subtract 10 from both sides. And I have 8x equals 88. Well, I'm going to multiply by the multiplicative inverse of 8, which is 1/8. And I now have a 1x on this side. That's what I would like. X equals 11, right? The question is, how old is who? Find Bonnie. Did I find Bonnie's age? Yeah, Bonnie was X, wasn't she? So Bonnie is now, because I don't know how old she is, right now, 11 years old. By the way, it doesn't ask, but how old is Shelby? Shelby is 7 times that. 7 times 11 is 77 years old. All right, good job, you guys. I will see you all in class.